Hi, science classes. So this is kind of your combined intro and lesson for the energy unit, the Reteach energy unit, potential energy, and kinetic energy. You often see me co-teach with myself in the classroom. And I'm going to be doing a little bit different today. I am down in the basement. I'm actually in the workbench corner. So I'm going to be really transparent with this. Got the computer sitting on the workbench. Got the study guide for our energy unit CFA pulled up on there. So that's kind of going to be my co-teacher here. And I'm going to be doing some demo stuff. I fully expect it's going to get a little jumpy. I'm going to try to splice this stuff together as best I can and make it one continuous video for you. Resources that we're taking a look at. I'm going to be, like I said, completely transparent. As I said, down here by the workbench, yes, really my tools, my tennis racket stringer, all of that kind of thing. Standing by the furnace. Got a couple of whiteboards, regular whiteboard like this. Got my tennis coaching whiteboard. I'm going to be taking some notes on there. We're going to get out some of the Hot Wheels track. And so our objective is just to reinforce what is potential and kinetic energy and how does it work. Get you prepared for the choice board assessments at the end of this unit. Made a separate video reviewing what's on those choice boards. Totally optional if you want to look at it. Just like I said, wanted to be completely transparent about what we're doing here. So what's going to happen, you're going to hear the voice of me coming off the laptop, at least hopefully you're going to hear it, explaining some of what's on the previous study guide, and then I'm going to do some example stuff using the Hot Wheels cars and some other stuff down here in the basement. Just kind of throwing paper towels around, that kind of thing, and trying to hopefully make it make sense to you. As always, if you have any questions, definitely reach out. Email me, send me a message on Google Chat, drop in during office hours on Tuesdays or Thursdays. Those times have been posted. Or send me a message on Google Classroom, and I will get back to you as quickly as possible. So that is our objective for today. Let's get started. My first topic of discussion.
Okay, so here's your review of the study guide, CFA2 types of energy. It's a little messy because I took some notes on it just to kind of save some time. We're going to do the back fully together. I'm going to review what we have for notes here. Where would you find the most and least potential and most and least kinetic energy of a rock rolling down a hill?
For us, we're going to use this car going down the track.
Most and least kinetic are actually the same spot. Least potential and most kinetic are the same spot. That being said, top of the hill has your most potential energy, so it has your least kinetic energy. Roll on down, whoop, most kinetic energy, least potential energy. It's all the way to the ground.
I'm going to demo that in just a second.
How that one works out. Explain in complete sentences why a Hot Wheels car stops after going down a ramp, even if it does not collide or run into anything. And many of you knew that's because it's of an outside force. That outside force is called friction.
Okay, and we're going to take a look at that one too. So here we go. We got, I don't usually let you guys use my Vettes and Camaros, but we are going to go ahead and use this one, the Corvette Stingray. Get that on camera so you can see it. So we got our orange Corvette Stingray. We can see here we got our track taped up to the toolbox, goes across the floor, and plenty of room in the basement unless we crash into that folding chair. So let's see how this goes, and then we'll get it labeled in just a second. Okay, so a little misleading because we did have an outside force acting on it. It crashed into the chair, but it turned and kept going. So relatively speaking, this worked the way that we want it to. Let's take a look at how we would label that for those two questions we just answered. Okay, so our car stopped on top of the hill. When I'm holding it in place like this, it's our most potential energy at the top of the hill. We can see, got all that height, and it's at the least kinetic energy because it stopped. It's not moving. Down over here, as it shoots past, which it's about to do, it's going to have the most kinetic energy because it's going full speed, but it's got the least potential energy. It's turned it all into kinetic. So there it goes. Okay, and over here it stopped. And of course we know it didn't crash into anything. You didn't hear it crash in the background. We can see it didn't actually hit anything over here. It stopped because of the friction running against my basement floor. So if outside force acted upon it, that friction gets released as heat a little bit. Floor feels cold, can't really tell because it's a small amount of heat coming from a Hot Wheels car. And of course all that kinetic energy, or all that potential energy is turned into kinetic energy, and it has been used up. So that is what's going on with that. Okay, I'm not even going to play the digital NEWAM here. I'm just going to go ahead and let you read the question there and read the answer. Claim of how potential and kinetic energy change form. It's exactly what we just talked about as we watch the Hot Wheels car run down the ramp and across the basement floor.
Kinetic energy, a 150 kilogram linebacker 15 meters per second, or the quarterback he is trying to sack, who's 97 kilograms and going 30 meters per second. How do you know? Make sure to explain in complete sentences and use information provided as evidence. So I'm not actually going to write the sentences part, but I'm going to show you how to do the math. We did talk about how kinetic energy we find by that formula of...
Okay, so our kinetic energy formula, I'm pretty sure I screwed up here. It's going to be 1/2 of the mass times the velocity squared. I'm going to go ahead and get that onto one of our boards here. Okay, so that's our formula, the 1/2 mass times velocity squared. And we have our two cars that... Oops, lost my tape. We have our two cars that are definitely different masses. The Raisin Bran truck and the Corvette. So we're going to run the Stingray first because it is lighter, and we're going to see if we can actually crash into it with the Raisin Bran truck. Okay, and then same height, but a different mass. So we're gonna, we should get a different, we'll see what happens. Okay, so I did extend the track just to make sure that they would actually hit into each other. This is related to that same question you just saw about the different weight linebacker and quarterback from the study guide. This is the same concept. The truck, because it's heavier, is going to carry more kinetic energy because of its mass. Now, if we were able to get the car going faster, let's say I had it from a higher height, something like that, then that would change the equation differently. Hopefully that makes sense. We did discuss this a bunch in class. So again, this is try to be review of what we've been talking about. So for the last part, we're looking at examples of potential and kinetic energy. One of the options in your choice board is actually to look at potential and kinetic energy around your house. So I thought I would just show a couple quick examples from down here. If I step over this way, I was doing a home project the other day, and I hung up this clip lamp on the beam. So it is hanging here. It is unlikely to fall because of the clip, but because it is... I'm 6'5", so it's about 6 feet off the ground, a little more. It has that potential energy for the gravity to pull it down, okay? So that's what we're looking at there. When we did the cars, which we can still see down here on the floor, maybe, yep. When we do these cars, they have kinetic energy when they are in fact moving. So this car right here, kinetic energy as it moves. That's what we're looking at with that. Now, what about potential turning into kinetic energy or having both at the same time? That is a possibility. I said I might do something with a roll of paper towels. I'm going to do that right now. So here's the deal. Got a roll of paper towels like this. When I toss the paper towels up in the air, that didn't work very well. When I toss paper towels up in the air, you can see them peak. So they have kinetic energy as they're going up, potential energy at the top, and then they come back down. Their potential increases as they're going up, and then decreases as they're going back down. So all the paper towels sitting on top of the basement freezer, they just have potential energy. When I toss them up, increasing potential, decreasing potential, but the kinetic is coming up as it goes down. So hopefully all that makes sense. That is all the topics that I see that we are trying to cover in the review of potential and kinetic energy. Check out that other video to see what's on the choice boards. Take a look at the practice before you go into doing your final choices, or at least I recommend that. And as always, take care of yourself and each other. Stay safe, wash your hands, we love you. This has been your lesson on potential and kinetic energy. Happy whatever day you're watching it.